Today, we see the next topic, move logic here, or move instruction. You can see from here, instruction list, I have taken a move block here. On this move block, you can see EN and ENO. EN means input enabled, ENO means output enabled. Means this block you can directly connect on network without any N or NC command also. Okay, so that is optional. If you want to connect any N or NC also, you can add here. Okay, so when the input is on, then only should move the value to the memory. Okay, for such purpose you can use input. Okay, otherwise I'm using this move block directly. So what is a move block? Move means you are moving some value, okay, to some another memory. Okay, like here I'm giving 300. If I want to move value 300 to MW4, this is a memory location where I'm moving this value. So it will be a fixed value. Like in this memory, it will be a fixed value. Okay. Whereas in the second case, you can see I'm using MW10 and output as MW20. Means memory to memory, I'm moving. So why I'm showing you showing these two methods here? Because in this method, it will be a fixed value. Whereas in this case, you can change the value. You can modify the value if you like. If you are to change the set point, okay, every 1 week or 2 week or every 1 hour, 2 hour, it depends. Okay, so I can use the memory to memory. So in this case, what happens? The first case, if I want to change any value here, again I need to download the program. Means when I am downloading this program block, total program is downloaded from the beginning, right? But in this case, you don't need to download the program once again. Just you can right click and modify the value. Okay. Now, the third method, in this example, you can see I have taken IW0 to QW0. IW0 means it's a word, right? It's a word address. IW0 means it is having 2 bytes. What are the byte numbers? Here you can see I'm showing in PLC simulator here IP0 and IP1. So these are the 2 bytes added included in IW0. So in this bytes we are having 8 bits, right? So total bits is starting from here 0 to 7, then 8, 9, 10, 11, 12, like this up to 15. Total bits from right to left is 16 bits. Okay. So here why I'm using this IW address here. Suppose I'm having a condition like 16 inputs, 16 outputs. Means one input, one output, like that I want to make on. Okay, I want to operate one input to one output. In that way, if I use one input to one output, I may need 16 networks. Right? I will need 16 networks, one to one input and output. So instead of using that 16 networks, I can use the move instruction here, where I'm using word to word, I'm moving directly. Means in one word, I'm having 16 bits. Similarly, I'm making the word for the output. QW0 means QB0 and QB1. Here also I'm having 16 bits. Okay. So let's see this example here. We go online. Now, here you can see value 300 is moving to MW4. Okay. Right now you are in online. If I want to change this value, I will make like 500. So what happened? It came to offline mode. You can see it is in offline mode. It is not running. At bottom also you can see run status is stop on hold. Again, you need to download this block. Then it comes to the run. You can see it is downloading the total block again. Okay, so 500 value is moving to MW4. Now this is one case. In second case, I am using memory to memory. So in MW10, this value 500, which is moved to MW20. So here, right click, modify some 15 or something, 152 something, right? So do I need to download the program block again? No, right? I can simply modify the logic here, value here, like something here. I no need to download this block once again in this second case. Whereas in this case, you need to download the complete block once again. Okay, there's a difference here. Okay, how you can use move that I'm showing. Then in this case, IW0 to QW0 and open this PLC simulator. This you can see IB0 and IB1. Okay, IB0 should be in the left side and IB1 at the right side for one word. IW0. Similarly for QW0, QB0 first, then QB1. Now, so here is the first bit here. When I make this input on, you can see the first output is on. When I make the second input on, second is also on. So like that, when I make each input on, the outputs are going on one to one. That means in move logic, in move instruction, if even if I use a byte, word, double word, okay. So here data is moving bit to bit. Okay. So in one word we are having 16 bits. So it is moving, whichever bit is on, that bit is moving to the destination, to the output. Okay. This is about the move instruction. Now this is a move. So you can use move blocks in series or in parallel. Okay. Whichever the way it is required. Okay. Suppose if I have to move the same value from MW10 to many locations. So in that case, I have to use move in parallel and have to give the same input and different output memory locations. Okay. So here I have taken W as a word. Okay. Word address for 16-bit only. If I have to move 32 bits, for that I can use ID0 also. Okay. For 32 bits. Okay. 4 bytes. Okay. At a time also you can use. So this is about the move instruction. So next topic is jump. Jump instruction. So what is jump? Jump means from one network to another network, I want to skip some output or just like for example, if I'm having two conditions, okay, if first condition is executed properly, then skip the or jump the second condition. You can see, okay. For such application, I can use this jump instruction. You can see JMP is a instruction here, which is coming as a coil in the output place. We need one input to activate the jump. So I'll do some others here like I0.0. Here for jump, we need to give some name like JMP1. Some name we have to mention. Okay, it will be a 4-letter for name only. A B C D. Okay, 4 letters. Okay, JMP1. So not only one jump instruction, you can use many jump conditions here. Okay, now I'll take two networks, some logic here like 0.1, 0.1, I0.2, 0.2. Okay, now I want to skip this two or jump this two outputs status. So in the next network number 4, I'll need to add label. Okay, label means for this jump, what name we are given JMP1, the same name we have to mention here JMP1. Okay, after this label, the logic will again continue. So I 0.3 and Q 0.3. Okay, download this logic. Now, so you have to observe here what is happening. Okay, when I give the inputs. Now, when I operate these inputs I 0.1 and I 0.2, sorry, so what is happening? The outputs are working here, okay, between jump and label, right? So after label also, if you operate the input, this logic is working. Now I make everything off. Now I activate the jump instruction here. Here you can see these two networks have been disabled. So even if I give the inputs here, the outputs are not going on. Means it is skipping these two networks. Okay. Then after label, if you operate the input, the logic will work. Okay. After label. If I remove the jump input off, then it allows these outputs to work. If the jump is off. Now here output status are in on condition. In this case, if I activate the jump, here it is disabled, but if you see here, the outputs are still on hold. It is holding the output status. Even if I make this inputs off, it is not executing this networks. Okay, but whatever the last status of the outputs are there, it is holding them. Okay, if the status of these outputs are off, it will be holding them as off. Okay, if they are on, it is holding them as on. Okay, so that is what is happening in the jump instruction. Okay, once again I will show you. Right now your inputs are off here for the outputs. Now I activate the jump. When I activate these inputs I 0.1 and 2, the outputs are in off condition. But after label, the logic will work as it is. Okay, it will continue from after the label. Okay, so if the jump instruction is off and you operate the inputs, the output will work as it is. If the outputs are in on condition and when you are activating the jump, in that case, even if the inputs are off, the output will hold as on condition, last status. Okay, so that is what is happening in the jump instruction. Similarly, we are having jump not, JMPN. This is a reverse condition for the jump. Means here you can see Not means what? When the input is on, its result will be off. If the input is off, result will be 1. So here you can see input is off, this is off. Whereas in this jump not, you can see it is shown green. Means without input also it is directly skipping these two networks directly. Okay. So even if you do the inputs here, the output will not come on. For that, we need to activate this jump not. Then only it will allow the outputs to work. Okay. After label, your logic will work as it is. Okay. In the program. So this is a jump not condition. Next, we are having program control instruction. So what is a program control? So for example, we are having some faults in the machine or some emergency buttons are required, okay, to stop the process, right? You need one button, okay, to control that process, immediate stop, okay. For such purpose, we are using MCR instruction. As you can see in program control, we are having MCR less than, MCR greater than. So MCR you can see below master control relay. Okay. So this is activate, deactivate, means open and close. So first of all, we need to make the MCR A, that is your MCR A activation for your zone. So here first we need to activate this on an empty network. We need to take this MCR A to make the relay on. So there is no need of an input here. Then with one input, we need to start this MCR. Less than means open bracket. Okay, starting your zone, and then the next network we need to close. There is no need of an input here for closing. Only for starting, we need an input. Okay. Now let's see how it works. So initially your I0.0 will be in on condition. Your input to the MCR will be on because your emergency push button, okay, is a NC switch. It will be in a NC condition. Means when you press that button, it breaks. So it opens. Okay. So what happens if it is NC there in hardware? Then we have to use NO. This will remain on. Okay. So this MCR zone from here to open to close, it allows this output or logic to work in between this open zone and close zone. Now your outputs are working here. If I press the emergency button, what happens? This input goes off. That button will break, means it is opening. So here your input goes off. Here you can see output status here. It is showing off condition. Means all the three outputs are off immediately. Okay, even though your inputs are still on. Okay, if I reset the MCR switch, again it is allowing your outputs to work step by step. It will execute from the beginning. Okay, within this zone. So if you press the button again, it will make all the three outputs off. Okay, so not only three outputs, you can use according to the logic from where to where you want to control. Okay, in the program. So this is about the MCR control. Okay. So you can add up one more condition, like one more zone if you want. You can create the zone like this. Also you can add up. Here also you can have some, this for another logic. So like for machine 1, machine 2, machine 3, machine 4, like that, you can have separate MCR controls, emergency buttons. Okay. So like that, different for different logics, you can add up this MCR zones. Okay. So this is about the master control relay. But first we have to use MCR A without any input here. If I don't want to use any more MCR zone from open to close, okay, after this I don't want to use any more MCR zone. For that I can use MCR D, deactivate. Okay. After that, if again you want to use, then again you need to activate after that, and then you can use MCR open and close. Okay, different zones you can add up here. This is about the program control.